Right, let's solve some trig equations, shall we? So I'm going to use a graphical method for doing this. I do that because it has links to many topics within the higher maths, and it's vital to be able to understand what's going on with that and draw the graphs. Even if you use a different method that works for you, that's absolutely fine for solving, but you do still need to understand what's going on with the graphs. So that's why I do it that way. Right, start with a fairly easy one. Cos x equals 0.6. So you find a calculator, you type in cos inverse of 0.6, and you find out it's 53.13 degrees or something like this. So let's look at number one. You do cos inverse of 0.6, and you get something like 53.1 degrees equals x. Done. Not quite done. Not quite done, because what's this bit got to do with anything? Well, it says that x can be any number between 0 and 360. And the point is this. The point is that so far we've found out that if I type into here, cos of 53.13, then I get the answer 0.6 more or less, which is what I wanted, right, for this. There's going to be another number that I could put in here and I'd still get the same answer. So to see why and how, let's draw a pretty picture. So we're going to draw a cos graph. Okay, here's going to be my cos graph. And it wiggles around a bit, doesn't it? It starts sort of here-ish, and it goes wiggle, 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 a bit like this. Obviously from here it kind of carries on and keeps going. No idea why I did that. It goes backwards as well, lots of wiggling going on. Here is the magic number 1. It's one of my favourite numbers. Life is simple with the number 1. Minus 1, 0. That crossing there happens at 90 degrees. And as I say, you need to know the shape of this graph. You need to be able to draw this graph and be familiar with it, even if you're not using it for this method. So that's why I just love to practice it as much as possible. Okay, so what's going on? This equation here says there's some numbers x, when if you put it into the cos, and of course this here is the x-axis here, and this is the y-axis if you like. So if you put in the number into the x, you get the answer 0.6. So for example, 53.1, that's sort of here-ish, right? Somewhere there. If you put in 53.1, you get the answer here, 0.6. If you like, y equals cos x hits the level of 0.6 in the question here at precisely 53.1 and a bit degrees. Where else does the same graph, the same wiggle, hit that same answer of 0.6? Where else is cos of something equal to 0.6? And we can find out there's a few of them. So if we go across at 0.6, here's one. Go across at 0.6, here's another one. And actually there's one backwards as well, there's one here. And of course they keep coming time after time, wiggle after wiggle. So how am I going to work them out? I'm just going to use a bit of kind of spatial awareness, a bit of logical thinking. So let's say, right, here's 0, I'm at the top. Coming down 53 degrees later, I hit the right height. So here is 360 at the top. Coming down the same distance, 53.1 degrees that way, I'm going to hit the right height. So where is this going to be? It's going to be at 413.1 degrees. Okay, 360 and then another 53.1. How about this one? It's going to be 360 at the top, and then if I go backwards this way, I need to go down this way. I need to go down 53.1 degrees to get to that same height again. So this one, I'm going to take away the 53.1, and I'm going to find out where is this is going to be 306.9 degrees. Because here's the top, 53.1 degrees below the top, and you get to the height we want. Same thing here, this is going to be going back 53.1 degrees, so minus 53.1 degrees right there. Okay, so there I've got my various answers. This is going to be 1 point. The other points are for Or x could be 306.9 degrees. Or it could be this, or it could be this, but it gave us that range there. So the only answers that fall within the range it asked us about are the original one and this one here. Just to check, in case you don't believe me, what if I type in cos of 306.9? Let's see what we get. 0.6 degrees. Sorry, 0.6 is my answer, essentially. So if x is 306.9, I get the answer I wanted. Great. Okay, so that's solving this kind of straightforwardish one here. I've got one of each type to practice to look at each graph. And I've also got kind of a few examples of slightly more complex things that can happen here. Okay, so let's have a little look at some of these, shall we? Number 2. Okay, I'm starting with 2 plus 5 sine of 3t equals 0. And what I'm going to do is have to first of all kind of solve the equation to get it into this kind of format to use the calculator, do the graph, do the stuff. Okay, so starting with 2 plus 5 sine of 3t equals 0. Let me take away 2 from both sides. Let me divide by 5 both sides. And I'm going to end up with sine of 3t equals minus 2/5, or negative 0.4 for the purposes of our calculator. Okay, so let's type it in, shall we? So when I type in, if I do inverse sine of both sides, see what happens here. See what happens here. Negative 0.4. I inverse sine, I kill off the sine, I'm left with 3t equals. So let's first type that in. Let's do inverse sine of negative 0.4, see what my calculator can help me with there. Excellent, I get negative 23.57, so 23.6 degrees for the purposes of this. Okay, that's good, but that's what 3t equals. So what I'm going to have to do at the end is that's what 3t is going to equal. So I'm going to branch out. I'm going to have t equals, obviously dividing that answer by 3. Now, it is good practice to use far more decimals than you need here. The reason I kind of haven't is just to keep it simple, and I'm using the graph to show you what's going on. But really, it is very good practice to do more decimals. So 5, 7, 8, just to kind of keep things accurate. So when I divide that answer by 3, I get t equals negative 7.859, blah, blah, blah. And I might just round it at the end if I feel like it, negative 7.9. Okay, there we go. So I've just divided that by 3 there. Okay, let's go ahead and find some more answers. Now, one thing is quite important. We have to figure out where the sine graph is involved. Okay, where is the sine graph involved? So if I have a look at my equations here that's going on, this is the point when sine of 3t equals something. Okay, this point here. The next step is when I do inverse sine of negative 0.4. Okay, so where the sine graph is just there on its own, it's getting from here to here, that I'm using the sine graph, using the inverse sine function to actually get answers off the sine graph. So, sine looks like this, and it keeps going, and it keeps going. Okay, we are looking for negative 0.4. Of course, it's 1 at the top, and it's minus 1 at the bottom. And we are finding that the answer, apparently, is minus 23, and this is where I'll just put 0.6, so you can just kind of see it more easily. Okay, so what have I done so far? I haven't been dealing with this section. I've been looking at using the sine graph at the point when I have the sine graph and then use the sine to get an answer. So here is my answer that I'm using. Inverse sine of 0.4 is 23.5, 23.6. Great. Where else does sine hit the same place, negative 0.4? Here and here. to help us get our heads around that, let's put in some numbers on here. So 90 is there, 180 is there, 270 and 360. So then let's try and figure out where on earth are these places going to be. Okay, easier one. See that 360 there, and then I'm going like from the middle downwards. Here I'm going from the middle downwards. So I need to go 23.6 degrees that way to get down this far. From starting here, I have to go 23.6 degrees this way to get down this far. So essentially it'll be 360 take away 23.6. You could use this exact answer really if you wanted to, that would be better. 360 take away 23.578. But in any case, what are you going to end up with is going to be 336.422 if you're using this precise one here. Okay, or more or less 336.4 if you're just using that one. This bit is easy, you just use a calculator. This bit, how did I know to do it? I look and see, right, where was like a key useful point nearby? What's happened since there? Here I was in the middle going downhill. It's like being at the middle here and going downhill. So I have to go 23 over to get to there. I have to go back 23.6 to get to here. Similarly, here, what's going on? Well, here I was at the middle, and now I'm going downhill out of the middle. How far do I have to go downhill out the middle? I have to go downhill by 23.6 degrees out of the middle to get to here. So it's 180 plus 23.578 degrees across to get from there to there to hit the same height, to fall down to the same height. Okay, so adding them up, I get 203.578 degrees. What are these answers for? These are answers for 3t. Here was one answer for 3t here. Here are more answers for 3t. Okay, so 3t could be this, or 3t could be 203.578, or 3t could be 336.422. Groovy. Okay, I can solve all of them very easily. So get my calculator out, do this divided by 3, and I'm going to get let's do it properly, 203.578 divided by 3, and you get 67 let's just say 86 there, and you get t equals 336.422 divided by 3. So you solve each of these equations separately quite easily. 112 obviously 0.14 degrees. I've got 3 answers so far for t. Right, now let's look back quickly to the question. The question said, find me all the answers please between 0 and 200 degrees. So let's just check. That one's no good to me, sorry. That one's good, that one's good. And the only question just to think of is, are there possibly any more anywhere? Is it possible that if I kept going over here, that there might be another one? Now, sometimes the answer might be yes, sometimes the answer might be no. Let's just work it out slightly. So adding on some more 90 degrees that's going to be 450 degrees. This here is going to be 540 degrees. That distance there, we know well, is 23.6, right? Like here, 23.6 degrees down, and you hit the right answer. So here, this one is going to be 540 plus 23.6 degrees. And where is that going to hit? That's going to hit 563.6 degrees. Really, I should be more accurate, and it'll be 0.578. And then that gives us 3t equals 563.578 degrees. divide it by 3. What does that mean for t? Will it be in my range? 563.578 divided by 3. Yes, 187.86 degrees. 1, 2, 3 solutions in the range. Then I should really go on and check the next one over here and see if it's going to be in the range. If I get one that's outside of the range, if I get one that isn't in this answer range here, then I know I can safely stop. Okay, at higher maths, it is normally just going to be kind of a couple of them. It's not normally going on far and far, but it can do on occasion. Okay, the next one, let's just do it in our heads, right? It's going to come back up. When it comes back up, it's going to be 720. That's 360 and another 360, right? Now, we want to be 23.5 degrees before that. So on my calculator, I'm going to type in 720 minus 23.578. Okay, this is where I'm going to be on the next round coming back up here. And if I divide that answer by 3, I get 200 something, which is too big, it's outside the range. So I can say with confidence that this, and this are my answers for this question. There are 3 places